Good day, everyone. Welcome to learning to understand the direct online starter for motors, or as it's commonly known, the DOL. So I have two example images here. Um, I've got these, I'll link where I found these. So basically what a DOL will have two main parts. It'll have the control circuit, which runs on a single phase line. And this actually this controls everything. It's how you start and stop the motor. Whereas we'll have our power circuit, which is where the three-phase runs into the motor. So we're going to have something that looks like this. We're going to have our three phases. We're going to have our three phases. And we'll have a neutral line. This will be our neutral. And our control circuit is going to take from one of these phases, and it's going to take from the neutral. So like here, this would connect here, and this would connect here. This will normally be our circuit breaker. This is where our first line of defense to switch on the circuit, our CB. This diagram is a bit weird, but it's fine. Our next thing we have, well, it says it's a fuse here, but this is normally a relay. A relay is basically an electromagnetic switch that allows us to control circuits and protect them from high currents. So what you'll have is you'll have a bunch of these little ports together, these groups of ports. And you'll power, and these ports might be normally open, normally closed, and you can put a wire into the one, and then the wire comes out, and then it acts like a switch. So you'll normally put this part in a normally closed switch. And when a high current comes, it will flow through this, and then this will open. When a high enough current flows through here, it opens these contacts, and then the circuit stops. So that's your protection. Then you'll have your actual start panel. So you'll have a start and stop controller, not controller, but panel. And your stop button is always normally closed. Unless we press that button, we want this thing closed. Otherwise, there's going to be no power through the circuit. But then we want our start button to be a normally open contact. That means unless we press that button, no current's going to flow through the circuit because it's going to be open. And then once we close that, we'll have a contactor. This contactor is another electromagnetic switch. It normally has this main point at the top, and then it'll have all these auxiliary switches. So we'll put a power in here, and this will be our contactor's main power, and then these are all the auxiliary contacts. So if this is powered, then these contacts are also powered. I believe a lot of relays are also like that. So the main point is, right, when this contactor gets powered, then we go to the neutral, and then the control circuit works. The only problem is, the second you stop pressing down on the start button, this circuit will stop working. So we need a way to to keep the circuit working even when the start button is open. And that's what this thing is. This is a normally open. So this comes from our start, and it goes to the neutral. This is our top part of the contactor. But then we'll have a switch that's a normally open. And we're going to wire this in parallel with the start. So what this ends up doing is the second this coil gets powered, this normally open will close. And once this normally open closes, well, now we have current bypassing the start switch, and then the coil can just keep running. But you notice the stop switch is outside of this loop. So if we press stop, both of these won't have power then, and then the contactor will close. So that's basically how the control circuit works. Now, our actual power circuit takes the power from all three phases. So I'll take power from here, and I see that this blue is actually green on this diagram, but it's fine. So it takes power from these three phases, and it'll run them through the circuit breaker. And now, normally in the circuits I've worked with and I've seen, this overload comes before the contactor. But it's fine putting it here. So what this will have, these relays, they'll have all these auxiliary contacts that are normally open, normally closed, so we can wire things with them. But they will also have a three-phase section where you can plug in three-phase wires to them. And then, so when the relay is powered, then the three-phase can just run through it. And that acts as protection. So if the relay trips either in the three-phase section or in the control circuit, it will be able to shut down the entire system. Then we'll go into our contactor. A contactor will also have sets of three-phase, with three coming in, with the red, like a red, yellow, and blue. Now, the thing is also with a contactor, when the contactor is powered, these are all normally open. So when it becomes powered, they close, and then this circuit closes, and the motor can immediately start up. Whereas the second this contactor stops being powered, these will open, and then the motor will stop. So that's pretty much the entire breakdown of how a direct online starter works. We have our control circuit wired to a single phase that consists of a relay going into a stop switch with the start going into a contact, and the start has a parallel connection with one of the contactor's auxiliaries. And in that, the relay and the contactor will both have the three-phase circuit wired through them so that the control circuit can stop and start the three-phase lines. And that's it. Thank you for your time.